So last video of chapter 3, and we're going to talk about inequalities. So we're going to graph these on a number line and then figure out what intervals are in the solution set. So first thing we're going to do is we're going to move all the numbers over to one side, so either the function is less than 0 or the function is greater than 0. Then what we're going to do is we're going to change that less than or greater than sign to an equals sign, and we're going to solve for the x values. So we set it equal to 0, solve for x values. These x values are our boundary points. So that tells us where our intervals stop and pick up again. Then what we're going to do is we're going to test these boundary points. So we pick an x value somewhere in that boundary point, we plug it back into our original equation, and we see what happens. After, that's going to tell us what happens in each of those intervals, and then we can figure out, well, what is the real solutions of this inequality. So let's start off with an example. It says solve and graph the solution set on a real number line of 2x squared plus x is greater than 15. So what we're going to do is we're going to move that 15 over to my left hand side. So now I end up with this. So this, my f of x is on my left hand side, so it's saying f of x is greater than 0. So that was all step 1. Step 2 is, well, take this now and let's set it equal to 0 so we can solve for our x values. So we can do borrow and pay back here. Now 2 times negative 15 would give me negative 30. Two numbers that multiply to negative 30 but add up to 1 are positive 6 and negative 5. So I get 2x plus 6 and then 2x minus 5 equals 0. So I can set each side equal to 0 now, and I get 2x plus 6 equals 0, which means x is going to equal negative 3, and then x equals 5 over 2. So those are my two boundary points. What that means is if you think about a number line, it goes from negative infinity to infinity. At negative 3 and at 5 over 2 is where I'm going to stop my points. So the first interval here is from negative infinity to negative 3. The second one is from negative 3 to 5 over 2. And then the third interval is from 5 over 2 to infinity. So those are the three intervals I'm going to concentrate on. And that's from step 3. So what we did is we solved our equation. Then we figured out what intervals I need to check. So that's number 3. So now what I need to do is I need to write my test value. So I'm going to set up a little chart just to make it easier. It's going to be 4 columns. Okay. First one is the interval that we just came up with. The second one is our test value. Third one, we're going to substitute it in. And fourth one, we're going to see what happens, so a conclusion. So my 3 intervals were negative infinity to negative 3, negative 3 to 5 over 2, and then 5 over 2 to infinity. So what I have to do is I have to now pick a test value. What that means is in that interval, pick a number. So from negative infinity to negative 3, I'm going to pick negative 4. From negative 3 to 5 over 2, I'm going to pick 0. And then from 5 over 2 to infinity, I'm going to pick 3. So it doesn't matter what number you pick as long as it's in that interval. Now substitute. What I'm going to do is I'm going to plug it back in to my equation. So I'm going to plug it into 2x squared plus x minus 15 is greater than 0. So this is going to be 2 times negative 4 squared plus negative 4 minus 15 greater than 0. So when I do that, negative 4 squared is 16. 16 times 2 is 32. 32 minus 4 minus 15. So 32 minus 4 minus 15 would give me 13. And I know 13 is greater than 0. So what I can say is that during this interval, f of x is greater than 0. So now we're going to do that same thing, same process with 0. So it's going to be 2 times 0 squared plus 0 minus 15. So when I do that, I get negative 15 is greater than 0. Well, that's not true. So in order for that to be true, it would have to be negative 15 is less than 0. So my conclusion here is that f of x has to be less than 0 in this interval. So my last one is 3, so 2 times 3 squared plus 3 minus 15 is greater than 0. So 3 squared is 9, 9 times 2 is 18, plus 3 minus 15. 18 plus 3 minus 15 is 6. And 6 is greater than 0, so I can say f of x is greater than 0. So I'm done with my chart. Now I just have to figure out, well, what's my solution? So up here, the first step we did, we said, well, f of x is greater than 0. So what we're looking for is where it says f of x is greater than 0. And I have those two intervals. So therefore my solution is the intervals negative infinity to negative 3 and 5 over 2 to infinity. So those are my two solution sets. So now that's it. That's all I have to do. So I want you to try the next example, and then try this example. You don't have to worry about this example, but then try these two examples as well. Okay? So try all of those, and then I will post the answer key. After this, you just have to focus on your review folder for the test.